Right, my little friends, I hope we're okay and everyone is getting on well in these unprecedented times, and the labs aren't too particularly taxing, and everyone's sort of getting on okay with them. We'll have a check-in this week, and then again in the beginning of December, just to make sure that everyone's getting on all right and everyone's okay during these unprecedented times, is the main thing to sort of remember. And today in Programming with Objects, we're looking at, it should be lecture 5, lab 4 I believe, and we're looking at loops, the while loop, the do while loop in that sort of format as well, and the for loop, which is probably the most powerful one, the best sort of one, and the game loop. Okay, so previously we've looked at blocks. So basically that's a sort of group of single statements that can be combined to form an unbreakable sequence, and these are essential to structured programming as well. And this part saying program control, I beg your pardon, I misspelled program there, it should actually just be program, not as in program, the Computer Games Development Program, but it should be PROGRAM, okay? Control, so we're talking about if statements, if else statements, if else statements as well, and switch statements. So we've looked at all of them. We've looked at sort of Boolean expressions and logical operators as well. So that should all be sort of a slight revision or becoming sort of prevalent in your brain. So we've looked at relational operators. You remember them from last week. The equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to as well. We've also looked at logical operators, so we've got the and, the or, and the not, and that's to sort of compound all of these things together when you're coming up with relatively complex if statements, okay? And remember the sort of operator precedence, and it's to evaluate expressions as well, and also control the program flow. Now, when I was sort of rewriting all of this, I noticed this by the sort of previous lecturer, and he's got this sort of slide that says ogres are like onions, and basically what he's sort of meaning about that is the layers, but he's really talking about program scope. So we have a number of strings here defined, so we'll get a dolphin, says click, an elk, which is a string, yes, bugle, what? An ogre does a bellow, fair enough, but the main thing to sort of take away from all of this is the ogre is defined in here, so the scope is in here, and then when you actually refer to it here and you refer to it there, it would be recognised because it's not within that particular block. So it's to do with scope and accessibility, okay? So because you've defined ogre in there, it won't be accessible there, and it won't be accessible there. And because you've defined elk in there, that will be accessible here because it's within all of this, but it isn't within this, okay? So essentially, if you sort of compile that, it will give you an error. It will say something along the lines of ogre does not exist in the current context, and ogre and elk doesn't really exist in the current context. So that's to make you think a little bit about your scope, and here we go again. Here's another sort of example. So you've got, it's pretty much the same. Oh yes, I think it's exactly the same actually. It's made that, no, it's not, it's more complex. Okay, so it's larger. Oh yes, so ogre doesn't exist within this current context. So you've got it within the, yes, the sort of context here. Doesn't exist there because of the blocks, so have a look at the block structure. And ogre and elk doesn't really exist here. So elk is there, and that cuts that off there. So have a look at your sort of corresponding brackets when you're actually defining a variable, giving it a value as well. So that's your variable type, your variable name, and your variable value, as we've discussed before. So remember that it only exists within these contexts of these blocks. It's all really about the blocks and making sure that you've got the corresponding blocks and that you can see where everything is accessible, essentially. So, and to me, it's perfectly logical. I'm sure for all of you will in the process of time become more or less perfectly logical as well. So you've got elk here, and that is accessible, okay? Ogre, it's defined here and defined there in two different ways. And while it's accessible here because it's within that particular context, it's not accessible here because it's out with these particular brackets, okay? And elk is only accessible within these brackets, yeah, the corresponding brackets, and not accessible in that particular context. So that's to show you a little bit about blocks, scope, and accessibility, okay? So today we're looking at looping, which is chapter 12 of the book. So read all of that. We've got the while loop, the do while, the for loop, and for each will come later. We'll then have a look at the game loop as well. And it's really in this book, chapter 12. Okay? So structured programming. In structured programming, the flow of control is limited to three forms really. You have the sequence, so that's where the statements are executed in the order. And then you have the selection, so that involves some form of decision. So that's your if statements, if else statements. So decision of whether a statement is executed or not, or choosing which statement to execute from a set of alternatives. Fair enough, so you get your switch statement as well. And then you get iteration, repetition, and looping. So that's repeatedly executing a statement, which is really the subject of this particular lecture. And you can do that in a number of ways. You can have indefinite loops, and you can have sort of or unlimited loops, and you can have loops that of course have a particular number of iterations as well, maybe go through it 10 times. You can control all of that, so it's important to sort of get that. Okay, so we create a loop so that we can repeat one or more statements over and over again until some form of condition is used to determine whether or not the loop actually stops. Okay, so the condition is either true or false, just like that used in an if construction. So you have a sort of game loop perhaps. So you start, you've got a sort of scenes loop, device input, render, and then exit. Yes, that can continually go round until some condition makes it stop. And once again, it can have a number of sort of loops in there. So there's a sort of loop section there. So iteration in C#, we have the while loop. So a conditional loop, which is only entered if the condition is true at the beginning of the loop, so we'll look into that in depth. We have the do while loop, which is a conditional loop, which is only repeated if the condition is true at the end of the loop. And loop statements always are executed once if you do this particular one, because it will do, and then the condition will have to stop is at the end. So it always enters the loop for the first time, and then if the condition then says that it should stop, it will, but it will always go into it once. Where it's not always the case with this. For loop, this is really intended as a sort of counting loop, and that executes a fixed number of times, and we'll show you how to sort of control that. That is the most powerful one, really. It gives you the most sort of degree of control. Then you have a for each loop, so that's a variant of the for loop, where the number of times is set by the size of a collection of data. So that's really sort of related to objects. And we can have a look at that later. But today we're looking at the while, do while, and the for, okay? So while loops. A while loop allows you to repeat a section of code, providing that that particular expression is true. So it has this particular format. So you have while, then your expression, and then a statement. You can have just one statement after it, and then that will be executed repeatedly. You don't necessarily have to have that in blocks if it's only one statement. But then you can of course have a sequence of statements within a block in order to repeat those statements, or repeatedly execute those statements while in the while loop. So once again, it's either got that sort of format where it's repeatedly processing one statement, or it can process a number of statements while in a sort of block, so your curly brackets again. Okay, the while loop begins by testing its sort of Boolean condition. So the condition is tested at the beginning of each iteration. If it's true, the loop body is then entered. If it's false, then the loop terminates. That is, the loop body does not execute, and control passes to the next statement. So it's all about the controlling the flow of the program. To avoid a while loop executing over and over, again forever, something in the loop body has to ensure that eventually that condition becomes false. If it doesn't become false, so obviously you're referring to the particular condition that makes it enter the loop, and you're changing that variable value within the loop in order for at some time in the future for it to become false. And if it doesn't, it will just loop forever and ever and ever. Come play with us, Stewie, forever and ever and ever. Okay, so it'll just go for indefinitely. Okay, and as the condition could be false the first time it's tested, the loop may iterate 0 times, may never ever in fact be entered. Okay, so here we have a sort of example. Once again, cannot stress this enough, you can just take all of the code, you can put it into the coding window and test this. I'm not giving you all this sort of code for the goodness of my health. It is in fact to help you with the labs, with the courseworks, with everything. So make sure that you know how to sort of execute these. You're supposed to go away and study these in depth, okay? So you've got your main procedure there. You've got an integer again, which is assigned to 1. Then you've got your while loop with a condition, and again, okay, is in fact equal to 1. If again is equal to 1, remember the difference between the assignment and the equal operators, okay? So what you're doing there is you're writing played an exciting game. I beg your pardon, it should be played an exciting game, okay? Would you like to play again? And you've either got to enter 1 or 2. That will take that in as a string, so again as string will be read straight in, and again has to be converted to an integer. In this case, int 32 I've made it. And then you pass that again as string into that particular function in order to convert it into an integer, okay? So essentially, cutting through all the jargon, it's supposed to say, you have played an exciting game. Would you like to play that game again? If you would like to play again, press 1, okay? And if you do, it'll ask you again, you played an exciting game. Would you like to play again? And if you continue to press 1, it will continue to go through the loop, okay? If you press 2, however, that condition is no longer met. It will then go to this, okay? And it will say goodbye. So that is essentially what you sort of get. Played an exciting game. Oh dear, I hate it when I make a spelling mistake in this, but I'm not running it again. Played an exciting game. Would you like to play again? I've entered 1. Yep. Here it's the message again. Would you like to play again? I've entered 1. Yep. Fantastic. Would you like to play again? I've entered 2. The condition is no longer true. So goodbye. Okay. So try that and try to correct the spelling mistake when you actually do it. A while loop allows you to repeat a section of code providing the expression is in fact true. So great. We've kind of covered that. So here we have it. Another example. You've got the player number is assigned to 5. While the player number is less than 10, okay, it allows you to enter a number. You've then got to do that particular conversion, and then if you enter a number less than 10, obviously what's going to happen is the loop is going to be iterated again and again and again. And then of course when that's no longer true, what will happen is it will exit the loop. So let's have a look. So enter number 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Enter 10, and then it's done. Okay. Fabulous. Right. So very, very sort of good for menu choices as well. So you can do that in a sense. So in this particular example, you have a Boolean value, menu choice needed equals true. Okay? So here, what we can do is we can cycle through everything and continuously show the menu. So you've got a sort of difficulty choice within there. This is a very, very sort of complex example. Please select your difficulty level, okay? 1, 2, or 3, easy, normal, or hard, okay? You're then converting that. You go into your difficulty choice, yep, and it will say easy, normal, easy, okay? Or that was a bad choice, or break. So you can, in fact, continuously go round presenting a menu again and again and again, okay? Now, what sort of should happen during the course of all of this is you'll notice that the menu choice needed is equal to true, but once you've made a selection, that menu choice needed is then set to false, meaning that it only goes around the loop once, okay? Of course, you can sort of call a procedure in order to display the menu. So that's a very sort of simple contrived example, meaning that you will only actually enter something once. But in this particular scenario, you've got to enter 1, 2, or 3, okay? If you were to enter a bad choice, it would then go round the menu until you enter a good choice. So it's a sort of good way of error checking, if I'm explaining that sort of properly. So if you were to enter 4, 4, 4, it would continue to go around that menu and offer you these choices every single time until you either enter 1, 2, or 3. And then when you enter 1, 2, or 3, the menu choice needed is then set to false, which means that comes here, set to false, right? And then it exits, okay? So that's what you sort of have there. Please select your difficulty level. 8, that wasn't a choice. 9, that wasn't a choice. That wasn't a choice. And then eventually you enter 2, normal, okay? And then that's it exited. And that's quite a good example. So have a look at that, see that you understand it appropriately, okay? Do while loops. This is a while loop. A while loop allows you to repeat a section of code providing that the expression is true once again. But in this particular scenario, this always goes into the statements at least once. And the difference is the while expression is evaluated at the end. So it goes in, performs these once, and then if that in fact becomes equal to false, then it won't do it again. But if it's equal to true, it'll iterate around it, okay? So, the do while continues while that is equal to true. And we can use a block to get more than one statement sort of repeated. So here we have this here, a sort of slight example. You're just simply setting an integer or assigning that to 0. And you're going round every single time printing the variable, okay, the value of the variable, plus 1, okay, while I is less than 20, okay? So if the addition didn't actually take place, or we subtracted instead, we would have a program that would run for a very, very, very long time. So you can put that into the coding window again, and that's what you get from the output there. So you get something that starts at 0 up until 19, and then eventually, while I is less than 20, that then becomes equal to false. It would go around the loop again. So a do while loop begins by executing its loop body. The loop condition is tested at the end, and if the condition is true, the loop body is repeated, and if it's false, then the loop terminates. As with a while loop, to avoid a do while loop executing over and over again forever, some statement in that loop body has to ensure that eventually the condition becomes false. And as the loop condition is not evaluated till the end, it's always executed once, so do sort of remember that. While loops and do loops can be used interchangeably. The reality is Most programmers use while loops, and that's because the condition is at the top of the loop, the top of the program, where everyone can sort of see it, or the programmer can see it. And the advantage is that the expression appears at the top without having to look at the bottom. Okay, so it's more logical for most people. So while loops are generally the sort of norm. That is reality. Okay. So there's a sort of diagrammatic representation of a while loop. Do sort of study these. I think they'll be in your sort of class test. So there you have it. While I is less than 10, you're going to be entering that loop. Notice that the I variable is altered, so you're incrementing that I variable until it becomes 10. Yeah. And then, of course, once it becomes 10, it will then exit. So continually go around that, outputting the variable. So it'll basically say, yes, it's equal to 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then once that's equal to 10, it will exit that, okay? Here's another sort of diagrammatic representation. So essentially, you're entering this while condition. While the condition is equal to true, this will execute the code, fair enough, iteratively again and again and again, until that's equal to false, and then it'll exit. Great, so here's the do while. So notice the slight difference in the structure. So do it'll execute the code, it'll get to the end, and then it'll evaluate whether the condition is true. If the condition is true, it'll go around it again. Okay, so it's always executed once until the condition is false, and then it'll exit that. Okay, here's another sort of representation. Okay, so that's what the code sort of looks like. Do, you go in there, the code block. If the condition is equal to true, it'll go around it again, and then if eventually that condition becomes equal to false, it'll exit. Infinite loops games, particularly complex games, generally have to operate in infinite loops until some form of condition occurs where that loop in fact exits. So you've got test, okay, this is a sort of example. You've got an integer test which is assigned to 10. Now this is an infinite loop. Well, test is equal to 10. It's just going to print out the value of test. So if you were to execute that, it would just be a constant stream of 10 forever. Now I'm not saying that's enough to sort of crash your computer, it wouldn't be, but I mean you'd be able to sort of see it. Okay. So do think of sort of while loops. Now, in terms of games, even if you're sort of talking about just a sort of simple first-person shooter game or a simple platformer game or whatever, maybe a while condition will be a sort of Boolean value while player is alive, or while player has life or a number of lives. Then you're going to continually refresh the screen, render all the graphics, all that sort of thing. And of course, when the player is dead, then that stops and it goes back to the main menu, or you respawn or something like that. Or perhaps it's a case of the game will continue until the player exits the game and decides that they don't want to play the game. So that's always sort of done with Boolean values. While player is playing or agrees to play or whatever, and that's equal to true, then fair enough, everything will execute. The game will be in a constant sort of loop. But after that, if the player decides to exit, or the player dies or something like that, then obviously you're exiting that loop. So fairly straightforward. The for loop, this is a very, very powerful one, has the following sort of form. You have a setup, a finished test, and then some form of update. So it's things we want to do a given number of times, essentially. So the setup, finish, test, and update are added to get the loop that we want. Okay, so it's the most powerful loop in C, C++, C#, Java, whatever, and it's the best sort of looping structure. So it's for initialization, so you can actually initialize these variables within there, which is great. You can define them, awesome. You can do the test, and then you've got the action, okay? So have a look at this. This is assuming that you were assigning an integer x, perhaps. Well, x is equal to 0. That's sort of assigned to 0, yeah? That's the initializer, okay? And while this is the test condition, x is less than 100, okay? Repeat this particular line of code. X++, so you get incrementing x, okay, every single time. So it's particularly suited for counting, moving through a sequence of things such as items and a character's sort of inventory. So this is done once at the start. You repeat while this is in fact true, and done after each iteration. So excellent, without it actually having to sort of change within the loop. Now, you notice that I didn't make a mistake, but there is a sort of slight difference in format there. This is assuming that the integer has in fact been defined prior. But you can define an integer within a for loop. So you've got for integer equals 0, I less than equal to 10, I plus plus. Now that will just simply print out 0 to 9. Okay? Absolutely fantastic. Then you can do sort of weird things as well. So you've got the integer I is assigned to 9, while I is greater than or equal to 0. So you're sort of decrementing this. Then that's the sort of testing condition. Then you're decrementing it, okay? And then you're basically going 0 up to 9, 9 down to 0. Yep. And then you're doing a sort of, you can even do sequences, which is weird. So this is your sort of 5 times table, okay? So this is another sort of way of doing it. These are a wee bit complex, to be perfectly honest. You'd probably just do something along these lines in order to control everything, okay? So you've got a sort of example there. So you get the for, the integer I is assigned to 0. While I is less than or equal to 50, you're going to increment up in 5s, okay? And then you're writing that out. So basically your sort of 5 times table. So that's what you sort of get there, as I said. So you have 0 to 9, 9 down to 0, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Brilliant, okay? So fire them into the coding window and see what you get, okay? For loops are particularly good for arrays or bidimensional arrays, and we will look at bidimensional and multidimensional arrays, I think, next week at some stage. So they're great for sort of navigating through arrays, okay? So essentially what you sort of do is you have nested for loops to go through each row, and within that, each column, okay? So you have a for loop to control the rows, going through all of the columns, yes? And then through all of the columns, through all of the rows, yeah. So that's what that sort of looks like. So you have a constant int rows. You can define all of this. The rows are assigned to 5, the columns are assigned to sort of 3. If you want, it is a self-defining sort of variable. You define what it is. And then you're actually, console.writeLine, you can print out the rows and the columns, okay? So what you're doing there is you're going through all of the rows, okay? And within that, going through all of the columns, okay? Now notice that this is in fact a different letter, has to be a different variable. If you call them both I, it will become very, very confused, okay? So I is assigned to 0, I is less than the number of rows, which is going to be 5, yep, okay? I plus plus, so you're going through all of these every single time. And then, to go through all of the columns, you're defining a jai. Now this is just hypothetical, of course. Assigned to 0, jai is less than columns, and then incrementing the jai as well. And what you're doing there is you're outputting the row, yeah, and the column, okay? So essentially that's what you sort of get, okay? So going through every single row and every single column, okay? So that's the way it sort of goes. You go to that one first, 0, 0, 0, 1, 0, 2, yep. Then on to the next row, 1, 0, 1, 1, 1, 2, yep. On to the next row, through all the columns again, 2, 0, 2, 1, 2, 2. On to the next row, nested for loop, 3, 0, 3, 1, 3, 2. And there's no way of sort of explaining that any better. You've just got to sort of get used to them, and it's probably quite important to sort of draw this and visualize it as well. So these are sort of multi-dimensional arrays, or we will look at multi-dimensional arrays. So for loops and arrays sort of go very, very well together. Okay. So that's just to sort of show you that. So the standard for loop structure, a part that's done at the start, the first iteration of the loop, a sort of Boolean condition that's checked, okay, before each iteration of the loop, and the loop is only entered if that condition is in fact true. And a part that's done after every iteration in order for the loop to progress, okay? And the loop body, the statements that are in fact to be repeated. So it looks like that. So for int x assigned to 0, x is, you've got to have semicolons. These are semicolons in between these, so these are like statement terminators. They've got to be correct. It can't be a comma, otherwise the compiler won't accept it. So semicolon here, so it's like a little mini statement. X is less than 100, semicolon, x plus plus, okay? Then you're repeating that particular statement. Done once at the start, repeat while this is true, and do after each iteration, okay? So for loops, sometimes called counting loops, because they typically execute a fixed definite number of times, so need to count their iterations, okay? So before the first loop is set, the count of iterations to 0, you've got to set that, and after each iteration, increment the count of iterations. So the condition tests whether the count has reached that required number. So set the counter to 0. Is the counter less than the number of iterations needed? Yeah. And add 1 to that particular counter. Okay. So the initialization part, the part done just before the start of the loop, is used to declare and initialize the loop variable. So be careful of that. You've obviously got to have some form of integer in there. Any variable you declare are local to that loop, so do remember that. So remember the scope, the sort of ogre example. And if you declare more than one, they must all be the same type. Okay? So you can also initialize variables declared previously as well. So the update or action part, the part done after every iteration of the loop. So this is intended to update the variable. So this is the last thing that happens in the loop before the condition is then checked again. And you can put other statements in this part in addition to statements that update the loop variables. So sometimes called a sort of action part as well. So a counting loop, there's a sort of representational diagrammatic structure. You're initializing the loop variables, you're entering the condition. If that is in fact equal to true, you have a block that's going to be repeated. Increment the loop variables, and then you go around that a defined number of times until that is then, the condition then becomes equal to false. Okay, so there we have it, the initialization, the condition, and the increment, the conditional code. Okay, so in we go, it's initialization, the condition, if the condition is equal to true, you're entering that code block and incrementing that, once again, round that as many times as specified. So it might be 10, for example, if you specified that amount in the condition. And then once that becomes equal to false, you're exiting that. So, as a number of nice examples for you to work through today. And when we talk about the game loop, we're talking about a sort of generalized representation of the flow. So it's quite a lot to take in today. So make sure that you sort of know that while loops, do while, for loops are probably your most important ones. Regardless of the type of game, these can be broken down into the same sort of repeating components. So loop choices, we have definite or indefinite. Is it going to go on forever? So can we work out how many iterations there will be at the entry point? If yes, it's a definite loop, so it's typically going to be a for loop. No, it's an indefinite loop, it's typically going to be a while loop, perhaps. Indefinite loops, 0 or more iterations, so there's an exit point, so it can be a while loop. 1 or more iterations, you're going to go for a do while loop, and then it gets a wee bit more sort of complicated. You can exit in the middle, perhaps, or whatever you're wanting to do with a sort of break statement as well. So prefer definite versus indefinite. Again, if you prefer a solution that uses definite loops over one that uses indefinites, then if you can structure the problem solution that way, then that's great. Only a definite loop is guaranteed not to loop forever. So do sort of remember that. And often you have no choice but to use an indefinite loop, as the problem might not actually allow you to predict how many iterations are needed to in fact solve it. So do sort of remember that. So remember that there are ways to sort of break out of loops as well. So have a look at this. Breaking out of loops, you've got number that causes a problem is in fact going to be 54. Okay, we've assigned that to 54 at this particular point in time. So it will go round all of this until it hits 54, and then within there you've got a conditional statement, which is a sort of if statement. F is equal to the number that causes the problem. So basically saying if x is equal to 54, then you're going to break that and you're going to exit that for loop. Okay. So that's what you sort of get. Goes straight up to 54. Now that's just a sort of example. You can of course start to input these things to exit these loops. You can of course continue as well. You can use the continue statement. So the number that causes the problem is in fact 54. But then after that, you can in fact go to the continue statement, put a breakpoint. Okay? So you can work it up to that particular point. Putting breakpoints is relatively easy. You just sort of click there at the side. So basically it hits that line of code and then it stops. But then of course you can then opt to continue in the code, and then it goes all the way up to 100 as previously sort of planned. So here's the sort of nested loop idea again. So think of the sort of example with the rows and the columns once again. So this time we're going through 100 rows, yeah, and 30 columns. And all we're doing is we're putting a little asterisk. And this is quite handy for putting things like histograms or things into sort of graphical programs as well. And we'll do more of that next year in software development for games, I think. Possibly we'll do it this year, I can't remember. But anyway, what we have here, if you fire this into the coding window, you've got going along a number of rows, 100 rows to be precise, or less than 100, so it's actually 99 perhaps. And then you're going along 30 columns. And then all you're doing there is you're writing a little asterisk. So what you get is just a sort of graphical display like that. And you'll notice that there's a bar here, so you're going down 100 rows or 99 rows or whatever. And then along here, there should be about 29 or 30 asterisks. Okay? Game loops, there's a sort of setup. It's the same sort of way of controlling these things. There's a setup, you get the player input, you update the game internals, you update the display. Is the game over? No, then you're going to do all of this again, maybe not the setup, but get the player input perhaps. And you're going to go round in a loop. That's how games and all software programs sort of function a wee bit. And then if that is in fact game over or you're exiting the application, shut down, yes. Okay, so accepting initial settings, loading assets in terms of games, sound, graphics, music, backup storage, yep. Get the player input. This can come from the mouse, the control pad, the joystick, the other devices, the keyboard, whatever. The game logic and rules are applied to the game, taking the user input into account, which then changes the variables and perhaps allows you to exit the loop. Yeah. You're updating the graphics and the display. That's fair enough. Then you address whether the game is over, and if it is, then the control branches back to getting input. Okay. Okay. Well, sorry. If it isn't over, it should be getting input, branching back. All right. And if it is in fact over, then you're exiting that. So the player is presented with a sort of final information, so the score or whatever to sort of round that off. Excellent. So what we're going to do for the purposes of assessment is we're going to have a wee guess the number game in the lab today as part of it. It's at the end. Now we have a sort of BMI assessment submission, which is 5%. We also have a sort of guess the number one now, and I will just sort of show you where that is in the assessment if I can find it. Not the assessment, the lab. Okay, so here's the lab today. Very, very simple. Loops. You're just sort of writing a program using a while loop that will prompt the user input until an integer value between 1 and 10 inclusive is entered. Then you're doing a while, do while loop, and then at the end, oh yes, write a program to display sequences, write a program that will read numbers until the score is greater than 1,000. That's great. So you've got some conditionals in there. You've got a dice rolling game, so you're sort of using the random number generator as well. And then at the end, guess my number game. The user has to guess an integer number between 1 and 100. The computer will let the user know the number is either too low or too high, so they'll be able to sort of narrow it down. And when they guess the correct one, they will be presented with a number of tries and add in a sort of play again feature. So that is quite complex. If you sort of work through all of that and you're doing the sort of if statements, the while loops and everything, that should all sort of formulate together. Okay, so I'll have a check-in session with everyone to make sure that everyone's okay. And if people are having difficulties, we'll sort of try and present some solutions to these labs as well. But it just really depends. But we'll have a check-in session just to make everyone make sure that everyone's kind of all right. Okay. So right to my little pals, have a try of that, and I'll catch up with you tomorrow because I'm doing this lecture on the Wednesday. But I'll catch up with you tomorrow for the engagement process thing. So I'll send out a link to that, or I've already sent out a link to that. Predicting into the future. But the week after that, there will be no lab, no lecture. It will be a sort of consolidation week. So just to sort of put you in the picture of that, that is the, if I can find my calendar, the week of the 12th, where normally I would have a sort of programming with objects lecture. There will be no lecture, no lab, so it's just enough time to sort of get you to catch up with everything. Okay, right, okay, I'll catch you later. Bye-bye.